Okay, this is the presentation about the main station. I'm Professor Julio Rezende. I'll be doing this presentation during today is the December 26th, 2020. And then these are some topics that we'll be talking about. And then I'm going straight to the presentation. And then we'll be mentioning about specifically about the main station. And then first I'll be talking about some ideas about the internal design. The internal design of this facility present uh, elements of some sectors of these facilities. We have the control center, management and communication, the dormitory, the training room, the dining room, the kitchen, one area of the gym spa area or recreational area, the research room, and a small vertical garden with plants for meals. And then we have one concept that we had uh, developed, also discussing with Davi about. We have in all facilities we have the plants aboard, like in vertical garden, but in the also we have a specific facility to food production is the greenhouse. Okay, but in each facility we have plants, and then some reasons to have the plants aboard as evaluates the air quality, also brings nature to space habitats. This is related to psychological well-being. This would bring less stress and more health, and also possibility of vegetables production, bring practicity and easiness to prepare fresh meal. Okay, and the concept pick and eat. Okay, in this case, this in the main station will be very useful because we have a kitchen that will be showing some photos. And then one of the sectors aboard of the main station is the control center with the functions of management and communications. And then one idea is have multitasking screens in the computers. Also, the multitasking screens is also used in the crew Dragon capsule, as you can see here in this photo. And this is very interesting because you can see also the evolutions of uh, the panels of the space vehicles. And now we have a concept of multitasking screen, okay, to control the activities in these stations, in the station. And then this is very important because you'll be using many systems based in software and hardware to control many activities happening in the entire station. And then we have a dashboard to control the entire station. This dashboard is considering elements related to greenhouse, the power station, sanitation, and health in the main station. And then we prepared these some topics that we are trying to control from the main station. In this case of operation of the main station, we need to control the some interior elements like the levels of water, food, temperature, humidity, and other elements. Also, from the main station, we are controlling the exterior activities happening, like this would be provide guidelines to extravehicular activities and energy supply because uh, sometimes we are happening variances related to the weather and temperature and lightning. Sometimes we have wind and dust storm, and then this was also would bring some difficulties to extravehicular activities. Okay, and then also if it's happening extravehicular activities of the astronauts, if they are using vehicles to collect the ice to bring back to the station, we need to know about the levels of oxygen of the astronauts and also the levels of the batteries of the vehicles, of the batteries of the spacesuits. And then you need to control this, because if the you need to avoid the danger to the astronauts during the extravehicular activities. And then the vehicles need to have a very good operation. And then in the main station, will be operating a system that, in the system, they will be controlling the elements of the greenhouse, like the levels of the oxygen and carbon, also the water demand from the greenhouse, also the temperature, the inner climate, also demands of the energy, because the energy applied to irrigation and lighting systems, also soil conditions, also the sensors in radiation, also the development of the plants. And then these are some elements that controlled by the greenhouse that the main station, the command, is interested about. Also, we are interested about some elements related to health of astronauts. These are related to mental condition, heart rate, calorie consumption, level of physical activity, blood, urine, feces, and other elements. Also, we are controlling elements from power station, communicating with the chief of power station to comment about the power generation in its sources, and the energy generated from kilopowers, solar farm, and biodigestion and other systems. Also, we'll be talking about with the power station chief about the consumption in the station, the demand. Sometimes, if you have the extra vehicle, if you have extra vehicle activities, will demand more energy to the recover the batteries to be used during the extra vehicle activities. Okay, then you need to plan how much energy they need for the operation of the vehicles, the distance that will be they will be doing the extra vehicle activity to collect the ice to bring back, also systems operation. And then relate to the sanitation, need to know about the generated gas, also the energy generated from the biodigester, also the sewage collector, source of water types, like if the water are coming from the toilet or from the food preparation, also which locations generating the sewage, and then how much water we are producing or recycling, and also the water received from extravehicular activities. Then how many kilos or how many liters are bringing back from the extravehicular activities. Also the ice that was is bringing back to the station, the water treatment, or and then also other how much water storage we storage that we have, also the airlock and other elements. Okay, and then the main stations try to control this all of these aspects here. And then we have a research room to be supportive about the analysis of these elements too. Also the elements that are bringing back from the extravehicular activities. Also the dormitory, also the in the kitchen, we are imagining the vertical gardens. Also, this is a robotic technology useful to prepare the meal. Okay, and then also the dining room, also the gym, and then it's very important the activities to avoid the loss, the bones loss. Also, we have in this case, in the main station, we are imagining not one facility but three facilities. These three facilities was named as Alpha, Beta, and Gamma. And then there was also a proposition from a architecture student from Brazil. Her name is Mariana Guerra, and then she proposed alpha model would be used for the prolonged use. It's a silent sector. It's important for resting. The beta model is for medium use and is a leisure sector. And gamma model is for scientific and working. Okay. And then also the alpha model, we have bedrooms and study room. Beta model, we have kitchen, dining room, and living room. And gamma model we have is for training, control, and research room. Okay, gamma model here. Okay, and then alpha model, we have bunks for the astronauts and also luggage storage and 2 bathrooms in a study area. Also, the beta model, we have the kitchen, also living space and a gym. And the third model, we have the research room, training room, and control room. And then some applied technology to be operating in the main station. We have some equipments like oven, fridge, virtual reality headsets, spa, hydro massage, disco lighting, communication technologies, antennas. And then in this case, almost everything will be transported from Earth, okay? But part of the food will be transported, will be produced in greenhouse. Related to management, we are imagining the 4 positions for astronauts to operate the main station. In this case, we have the commander, someone with a multidisciplinary background, someone from management or industrial engineering, someone with high capacity of leadership, high personal resilience, and the commander will be controlling the extravehicular activities. Also, this will be integrated with engineering center, also proposing routines, operational protocols, proposing guidelines, conducting the educational activities, preparation for extravehicular activities, also coordinating daily communication with Earth, in this case, the international space agencies like NASA, ISRO, or other space agencies based in Earth, based on Earth. And then the second position is the executive chief, is someone of is an engineer or information technology specialist. Some duties are monitor all operations, keep all facilities running, monitor the routine maintenance, organize specific operations, coordinate trainings, and organize specific operations possible people, stimulate self-sustainability. Okay, and then the third position is the chef, would be someone with a professional background as a cooker, cruising chef, nutritionist, or a gastronomer. And some duties are define the menu, also the prepare the meals, think about food logistics, perform food preparation, waste disposal, cleaning, organization, maintenance, and repair procedures. Also assess the team's nutritional requirements. Also plan the availability of food and define the feed shifts. And then is this first figure. The first figure is representing the character Neo in the movie The Matrix, and then he's in this photo. He's aboard of the Nebuchadnezzar ship, and then in the Nebuchadnezzar ship, he is also consuming the oat milk, and then he's complaining because this is very boring. Eats this meal every day, and then one of the responsibilities of the chef is provide interesting and creative meal based in a combination of a meal transported from Earth. As you can see here, the photos from the astronauts package of the astronauts meals, and also combine the food transported from Earth with the food produced on Mars. Okay, and then in this case, it's a photo from some meal from Habitat Marte. We have it's possible to see the basil, pepper, and lettuce in this photo. Okay, also in Mars, we need how we'll be combining these two sources of food. Okay, and then the fourth position is the assistant, is would be an engineer and information technology technician or a psychologist. And then some responsibilities are emphasize the well-being of the crew, uh, creating the interesting content to entertain the crew. Also food management, support the chef, coordinate the organization of dormitory, the gym, and also manage laboratory tools, study routines, and sample analysis. Also apply psychological surveys. And then we are imagining about the astronaut training program. And then some topics of training are the new skills based on situations identified in Mars, also systems operation, new technologies, positions and tests of each astronauts and simulations. And then we identified some useful videos that would be used for the astronauts, like the Make Things Work, How to Manage Your Mental Health, Baroque Music Collection, Occupational Safety and Health, and Build Resilience. And then other, in these cases, we are only mentioning some videos here, but the database would be very large to provide different content to the astronauts. And then these are some resources necessary for 1 week. And then we have imagine 1 kilo by day by each astronaut, for each astronaut. Also 2.5 liters uh, to prepare the food, and also 2 liters by day for each astronaut. And then it's necessary to make also multiply these numbers for the number of astronauts and number of days necessary. And then some guidelines to provide to other facilities. In this case of the main station, we would like to provide the daily routines and schedule activities, guidelines about the health occupation, also the health environment safety guidelines, how to maintain plants in the specific space habitats, provide harmony and collaboration, and make astronauts comfortable about to be in space. Also stimulate cooperation, innovation, creativity, and co-creation, emphasize the team's well-being, create interesting content to entertain the team, also stimulate the self-sustainability. And then now we are going to the fourth dimension of this presentation. We'll be talking about some protocols. And then we have some specific protocols like relate to harmony and good relationship, protocols to deal with stress in the relationship, protocols to organize the room, protocols for plant maintenance, protocols for food production, infrastructure maintenance protocols. And then related protocols to safety, we need to hygiene protocols. Also, we need to know about the some weather data like health rate, calorie consumption, physical activity level, saliva, blood, feces, and urine samples, protocols for dealing with psychological balance and emergencies, protocol simulation to deal with accidents, and also the protocol for entertainment. We need the to think about the parties, celebration days like Spa Day. Now we are during the holidays times. Also in the International Space Station, they are celebrating the Christmas, and then we are imagining that during this time in Mars, also they would be celebrating the Christmas days too. Also, in terms of occupancy, you need to think about the board games and yoga and physical exercise protocol, and also reading and contact suggestions. And then in terms of our vertical garden, we are imagine a protocol like a protocol for cultivation, protocol for maintenance and detection of adjustments, and management of the plants, food collection protocol, protocol for rotation, disposal of the plants, best time for irrigation, male-female pollination, in plant cycle, plant lifespan. And then about the 3D printing process, we imagine that possibility to using the clay to produce some ceramic utensils like pots, okay? And then some material product to be 3D printed, like the utensils like plates and mugs, okay? And then you need a vast 3D models database to be printing these utensils. Also, as we imagine the product degradation and recycling protocols like discarded items are ground down to particles. Also, ground plastic further, refining into smaller particles in a blender. Also, small particles melted and extruded into a plastic filament for 3D printing. And then from this, from the plastic filaments, we would be developing the additive manufacturing printing process with the recycling filament. Okay. And then now the last part of my presentations is about the spin-offs. Spin-offs are some results from the operation of the Mars base or the Mars habitat that would be applied to Earth. And then some technologies outputs that could be applied on Earth would be the water saving, energy saving, also recycling mindset, and then also guidelines to be applied in our daily life in Earth is related to mental well-being, daily routines and guidelines, health occupancy, also health, environmental and safety guidelines. And then at least my last slides about the impacts to sustainable development goals. We mentioned that we are about our activities in the main station would have impacts related to health and well-being. Also, the training of astronauts is related to quality of education. Also, it's important for us. We have the women in our crew. This case is related to the gender equality. Also, water savings related to clean water and safe water. Also, we are very interested about saving energy and also the waste recycling. Waste recycling is connected to goal 50. Also, the goal 16 is related to the transparency, communication, and management. And also, goal 17 is related to partnership because we will have the participants from many countries in the aboard of the station. And then also we will have the cooperation between the many different space agencies, and then partnership will be a very important element. Okay, and then this is my last slide, and then thanks so much for your attention about this presentation. Thanks so much.